It is my genuine pleasure and a distinct honor to introduce tonight's keynote speaker and my former PhD mentor, Bob Bjork, a distinguished professor of psychology at UCLA. Bob has a rather remarkable set of qualities that over the years of his career have made him a leader in the field. But for those of us who know Bob's work scientifically, one can't help but admire the perceptive and insightful theoretical analysis, his perceptive and insightful theoretical analyses, as well as his creative and elegant experimental investigations in human memory. But what has allowed Bob's scientific talents to truly shine are basically two qualities, one being his remarkable talents as a communicator, and the second is his long-standing commitment to ensuring that the work that he did, and in fact the work that we all do as cognitive psychologists, to have their maximum positive impact on the field, on people in general. In fact, over the years, Bob has worked very hard to see the very best in what each of us does, and through his positions as a leader in the field, tried to ensure that what we do as cognitive psychologists positively impacts the public interest. A few highlights. Bob got his bachelor's degree in mathematics from the University of Minnesota in 1961 and his PhD in psychology from Stanford University in 1966 under the mentorship of Gordon Bauer and Bill Estes. His first faculty appointment was at the University of Michigan in 1966, and he rose through the ranks very quickly to full professor in 1974. In 1974, he transitioned to UCLA as professor of psychology, where he has remained ever since. And Bob was chair. Well, I guess that doesn't work. Bob was chair of psychology. There we go. This happened to Suparna last year. Suparna, I have empathy for you now. Bob was chair of the Department of Psychology from 2003 to 2010, and because of his incredible contributions to the department and to the university and to the field as a whole, was awarded the rank of Distinguished Professor of Psychology in 2005. And indeed, Bob has been received many honors and awards over the years. So he's been elected a fellow to most of the major professional organizations in the field, and in fact has received distinguished awards in virtually every category of professional activity that we all do. He's received a Distinguished Teaching Award, Distinguished Service Award, Mentoring Award, and of course numerous awards relating to his scientific accomplishments. And Bob's record as a leader in the field is nothing short of breathtaking. So he has been the president or chair of virtually everything. Virtually every professional psychological organization in the United States, as well as being the chair of various councils and committees that are of great importance to the field. And I'd like to highlight one in particular that just does not work. It was chair of the governing board of the Psychonomic Society in 1988 and 1999. And I should point out that Bob has actually attended every Psychonomics for the last 40 years, making him one of the most dedicated and longstanding members of this society. What commitment. Bob's leadership is also reflected in generous terms as editors of some of the leading journals in the field: Psychological Review, Memory and Cognition. He was an action editor for Cognitive Psychology. And I'd like to point out, actually, I bought a backup laser pointer. I'd like to point out that he was one of the co-founding editors of Psychological Science in the Public Interest with Stephen Ceci, which I think illustrates rather vividly Bob's commitment to ensuring that psychological science makes a real contribution to society at large. Bob also has worked hard to train the next generation of scientists, and it's a rather dizzying array of graduate students and postdocs that you can see illustrated here, and many of these people who have gone on to highly successful careers both inside of academia and outside, and I'm sure you'll recognize many of the names on this list. And I think everybody on this list would agree that they look back on their time with Bob as their mentor with great fondness and great appreciation for the values he brought as a mentor. Perhaps Bob's most profound contributions to our field come in the form of his scientific research on long-term memory, in particular his work on retrieval processes and inhibitory processes in memory. He has received funding from most of the major funding organizations in the United States and has made seminal contributions in at least 4 major sub-areas of memory: intentional forgetting and inhibition, meta-memory, retrieval as a memory modifier, the idea that retrieval is not a mere measurement of memory, but actually impacts the state of memory, and also work on and writing on training and enhancing human performance. In each of these areas, he's made seminal contributions both empirically and through incisive theoretical analysis, and not unimportantly, through his talents as a communicator and his capacity to inspire interest in others in taking up these very interesting subjects. And I think that much of this enthusiasm was on vivid display about a year ago at the Bjork Festschrift, aka the Bob Fest, about January of last year, which was held at UCLA and organized by Aaron Benjamin. And many of Bob's former trainees and collaborators joined together there to give wonderful presentations on the work that they did that was inspired by their time with Bob. And anybody, for those of you who have missed this, the book is outside in the hallway, an edited volume, edited by Aaron Benjamin. I think most people, I think most of the people who have worked with Bob would agree that I would be remiss if I didn't mention one important point. And that important point is that much of the work that Bob has done, in fact, Bob and Elizabeth have done. Bob, I think we really should be honoring both Bob and Elizabeth today because they've had a joint laboratory over many years and have had a joint research program. And I think everybody on that list of people that I put up before would agree that Elizabeth Bjork was an invaluable mentor to them as well. Here to Elizabeth. I think also I should say that on a personal note, Bob and Elizabeth have served as a role model for all of their students and trainees, both with respect to their professional collaboration, but also with respect to the way in which they balanced the personal and the professional. And so over the years, I don't want to speak for my colleagues, but I myself have often found myself in thinking about professional issues or the balance of professional and personal life, asking the question, what would Robert Bjork do? So it is my great pleasure to present to you today's keynote speaker, Bob Bjork. Thanks.
Thanks so much for that absolutely wonderful introduction. I appreciate it so much, especially the exaggerations. Two things aren't exaggerated. One is my commitment to this organization. I actually gave my first professional talk in 1965 at this society as a graduate student. The rules were different then, I guess. And unless I've forgotten something, I haven't missed since. So that makes maybe 45 or 46 years instead of 40. Also not exaggerated is the role that Elizabeth's played in anything that I've done, and that'll get pretty clear today. In 1965, one reason this honor you can't sort of imagine how important it is to me is this society has been kind of a professional stimulus for me, a source of ideas, not just in the paper sessions, but in the hallways and over coffees and over meals, all during this time. And there are many, many memories, including in 1965, getting a call from Clyde Coombs asking me if I wouldn't join him with Robin Dawes and Amos Tversky to talk about possibly moving to the University of Michigan. So the society has been extremely important. I will say, however, that there are a couple of memories that are less than cherished. One of them actually dates back to that 1998-99 period. At the 1998 business meeting was where it was announced that I would be the next chair of the society. The only problem was that I forgot about the meeting. And what made it somewhat worse is I had been actually kidnapped and dragged off to watch a UCLA USC football game in a sports bar. And this group of us came back down a hallway just as it opened and the rest of the board walked out. The look that Bobby Klatsky gave me as the outgoing chair is still in my mind somewhere there. Okay, today I want to do a sort of overview of human memory, particularly how remembering, forgetting, and learning interact, and sort of an interpretation of that interaction in terms of a theoretical framework that Elizabeth and I call the new theory of disuse. In trying to do this, I'm reminded of an effort to give a broad talk on memory now 30 years ago. It was an after-dinner talk to the Harvard Radcliffe Club of Southern California in Santa Barbara on the beach. Our whole family got to go. It was a wonderful thing. Before the dinner, Elizabeth and I and our two young sons were checking out the podium, checking out the banquet room. And at one point, Elizabeth and I heard the speaker go on, and there was our oldest son, Olin, then about 8 years old, doing this imitation of his father. And he said, "Ladies and gentlemen, the memory's in the brain. The brain is in the head. Any questions?" I later went on for about an hour saying more or less the same thing. Actually, we do know quite a bit more now. And one of those things is that human memory is characterized by a sort of remarkable symbiosis of forgetting, learning, and remembering. So forgetting rather than undoing learning, as I'll talk about in a moment, enables learning and focuses remembering. Remembering creates learning and produces forgetting. Learning begets, don't put your finger over it, okay. Learning begets remembering, contributes to forgetting, and enables new learning. Now, equally remarkable, however, is the system seems poorly understood by the user. We carry around a flawed mental model of how we learn and remember, or fail to learn and remember. Our assessment of whether we have learned or will remember later are unreliable, sometimes dramatically wrong. We manage our own learning in far from optimal ways. We seem not, in short, and surprisingly, to be informed by the trials and errors of everyday living and learning. So this interaction of remembering, forgetting, learning that I want to talk about is characterized in the new theory of disuse that Elizabeth and I put forward. And a sort of starting point for this theory is that information in memory, no matter how overlearned, how automatically accessible at some point, street addresses, phone numbers, friends' names, with a long enough period of use, gets inaccessible. But we know now that that information remains in memory as measured by recognition, priming measures, and especially relearning. Now, the original law of disuse said that without memory representations continuing to be used, they decayed and were gone. That's Thorndike's law of disuse, and it stands as perhaps the most thoroughly discredited law of all the laws in psychology. That's a tough competition. It's important to emphasize, though, that Thorndike was not all wrong. Use does matter, and using the system shapes our memories as also. And basically, in our new theory of disuse, a starting point is we argue that the unused memory representations do not decay, but they become inaccessible. Now, the theory, in addition, is motivated by this set of important peculiarities of human memory. They're important because they're trying to tell us something. They're peculiarities because they are ways that human memory differs from man-made memory devices. So a remarkable capacity for storing information is coupled with a highly fallible retrieval process. What's accessible is heavily queue-dependent. Retrieving information is a dynamic process that alters the subsequent state of the system. Access to competing memory representations regresses to the earlier representation with time. And conditions that produce forgetting often enhance learning. So let me start out by just talking about this last important aspect of human memory and just show you a few example studies, including this one from 1970. Elizabeth told me, don't remake, show some of those old handwritten ones. People will enjoy seeing. So you're going to get a few of the old handwritten. So this is a study by Bjork and Allen. What participants had to do, they saw a set of 3 words in the window of an apparatus. They then either did an easy or a hard shadowing activity before having to recall those. And not surprisingly, when you're tested, you remember more, a higher percentage, after the easy activity than you do after the difficult activity. But we also included conditions where instead of testing there, we gave people a second presentation and then gave them 20 seconds of a medium difficulty activity, tested people, and now it turns around. The condition that produced the most forgetting, measured there, yields the best performance measured there. Similarly, we know from work on context effects that if we study something in room A, and then at some later time are back in that situation rather than in another situation, a new situation, in general, if not always, we recall more when we're back there. But if instead of testing people, you let them restudy the information, either back in the same room or a different room, then let time go by and test them in a neutral context, then it turns around. And the condition that produced the most forgetting here yields the best performance there. And finally, of course, sort of the ultimate example of forgetting produces learning is the spacing effect itself. If there's a study trial, after a short interval, if tested, we'll remember more than we will after a long interval. But if instead of testing there, we present the information again and then wait a long time, we'll get better performance in the case where there had been more forgetting there, and sometimes a very large difference. Now, it turns out the converse is true as well. So if we prevent forgetting, we can nullify learning. Just a couple early examples, one by Jim Greeno. In this case, the subjects were learning a paired associate list by the so-called anticipation method, where you'd see a stimulus, try to say the response, see the response. The only different thing about it is some of the items, a few of the items, had an immediate masked presentation within the list. So they were presented once and then presented right away again, in which case the subjects, as you can see by the dotted lines going down, were essentially perfect on the second trial in each list. But what you can see here is that second trial did nothing for the learning. They were the same long-term as the single presentation case. And in a similar way, dating back to my own dissertation work, in which I looked at the interaction of short-term and long-term memory and acquisition of a list, looked at as a function of random sequences of interpresentation intervals, looking at both reaction times, that's the bottom curves here, percent correct, the top. I was able to fit this all very well with a Markov model that distinguished between learning states. But interestingly, the best fitting estimate said that the probability of learning once you were in the short-term state was exactly 0. So there too then, we can prevent learning when things are too accessible. Now, here's the assumptions of the new theory of disuse. The first assumption is that items in memory are indexed by two different strengths. A storage strength, which is kind of the degree of what we might call learning, how entrenched or interassociated a memory representation is with all the things it's related to in memory. A retrieval strength, the current ease of access, how primed or activated the item's representation is at memory in a given point in time. And in the theory, retrieval strength completely determines probability of recall. Now, this distinction's hardly new with the Bjorks. Estes, in a very important 1955 paper, said the two principal aspects of learning distinguished in contemporary theories are habit strengths, change in resistance to extinction or resistance to forgetting, that's storage strength in our terms. Response strength, changes in momentary probability, rate, or latency response, that's retrieval strength in our terms. And he pointed out that the distinction corresponded to habit strength and momentary reaction potential in Hull's system, and that even Skinner had to distinguish between reflex reserve and reflex strength. And roughly, this corresponds to the time-honored distinction between learning and performance. And when you want to say that something's really an old distinction, what do you go back to? Ebbinghaus. And this is from the Woodworth and Schlossberg, a wonderful experimental psychology book. And what they point out is that every time Ebbinghaus relearned the list to one correct recitation, he did it faster every day. So he reached the same point in terms of kind of retrievability or retrieval strength, but then went faster the next day. And so what was not remaining the same was something like storage strength. Okay, what is new in the theory is how storage strength and retrieval strength interact. And the second assumption is that storage strength grows as a pure accumulation process. It's a monotonic function of storage, of a study or recall activities, and it's permanent. Now, it's kind of a simplifying assumption, but basically says what you accumulate in long-term memory in the way of storage strength stays there. It's negatively accelerated function of both current storage strength and retrieval strength. Now, the negatively accelerated part with storage strength just makes sense. The more you have, it's diminishing returns, the less you can gain. But an important part in the theory is that the higher the current retrieval strength at the time something's studied or recalled, the lower the increment in storage strength. Assumption 3, whereas there's no limit on storage capacity, there's a distinct limit on retrieval capacity. That is, on the total number of items that are retrievable at any one point in time to a queue or set of queues. And to be recallable, an item must be sort of discriminated and reconstructed, and that is a function of its current retrieval strength. Now, how is retrieval strength gained? Well, retrieving an item and studying an item both increment retrieval strength and storage strength, but retrieving successfully is the more potent event. That's crucial to predict a number of phenomena, as I'll indicate why. Increments in retrieval strength are assumed to be a decreasing function of the item's current retrieval strength, so the more you have, the less you can gain. An increasing function of the item's current storage strength. So what that says, that storage strength is a latent variable that enhances the gain of retrieval strength and retards its loss. With respect to this notion that retrieval is more potent than study, we, in the last year's keynote address, heard multiple examples of simply how powerful retrieval is. And this is one case in which recently, Science Magazine, what Jeff Karpicki and Roddy Roediger did was a standard vocabulary learning, Swahili English vocabulary learning experiment, where there'd be on a bunch of pairs, first a study phase, then a test phase on all of them, then a study phase, then a test phase. What their gimmick was, to contrast with the normal thing where you'd go through all the items on each study and test phase, they had a condition where once an item was correct on a study trial, you dropped it, test trial, you dropped it from any subsequent study trials. Another case where once it was successful, you dropped it from any subsequent tests. And a third case where you dropped it once it was successful from both subsequent study and subsequent tests. This is performance a week later. And as you can see, as long as it was kept in the test cycles, you're as good as where you studied and tested on it each time. If it's dropped from the test cycles, you are down here. Interestingly enough, and relevant to other things I'll come to in a second, in all of these conditions where subjects were asked to predict their performance, upcoming performance, they all predicted about 50%, no significant differences. How retrieval strength is lost. So decrements in an item's retrieval strength owing to the learning or retrieval of other items is higher the item's current retrieval strength, so the more you have, the more you can lose, lower the item's current storage strength, and as I said then, storage strength, a latent variable, acts to enhance the gain and retard the loss of retrieval strength. Now just schematically to give you some feeling for this, assume these are 4 hypothetical items in memory, and this one is high on retrieval strength, low on storage strength. This one's low on both, that one's high on both, this one's high on storage strength, low on retrieval strength. This, for example, might be your hotel room number here, which for the next couple days will be very accessible given high retrieval strength, but a few days or a week from now will be lost given its low storage strength. This might be an address or telephone number that you had 20 years ago and had for some period of time and knew very well at some point but cannot now recall. What's important now is if all of these are shown for study, this shows the increment predicted by the theory in storage strength and in retrieval strength. And the only thing I really want to have you notice for sure here is this important asymmetry. The higher the level of retrieval strength, the bigger the gain in storage strength. But the higher the level of retrieval strength, the smaller the gain in storage strength. That asymmetry turns out to be crucial to account for a number of phenomena. Now, as far as effects of intervening items, then if you're high in retrieval strength and low in storage strength, you lose a lot. If you're low in retrieval strength, high in storage strength, you lose very little, and those are in between. Now, a few predictions of this framework. I put predictions in quotes because the theory was, these informed the theory in advance. We wanted to account for these phenomena. Effects of overlearning and repeated learning. So that goes back a long time in the history of research on learning and performance. But as you give overlearning trials past the point that performance is changing and nothing seems to be happening, you slow the subsequent rate of forgetting. So these additional trials can keep enhancing storage strength even if retrieval strength is at some kind of maximum. Yost's laws, I'll show in a second. Interaction of the spacing interval, retention interval. Retrieval is a memory modifier, regression, recovery phenomenon. I'll say a little bit about each. Yost's laws dating back to 1897. If 2 associations are now of equal strength but different ages, the older one will lose strength the more slowly with the passage of time. What equal strength means is equal recallability. That means equal retrieval strength. And if they're equal now but one's older, it has to have higher storage strength. Number 2, if 2 associations are now of equal strengths and different ages, further study has greater value for the older one. So again, if they're of equal strengths but different ages, the older one has to have higher storage strength, and it will therefore experience a bigger gain in retrieval strength. Now the spacing effect, and actually reverses at short retention intervals. We talk about the advantages, and in a way this top is the spacing effect. But the truth is, if you have a very, very short final retention interval, then massing can be better than spacing. And what you really need to be able to predict in any theoretical framework is this interaction of the spacing interval and the retention interval, a kind of litmus test for any theory. And here is a simulation that comes. This is one that's not my handwriting. It's actually Catherine Fritz's handwriting. But what this shows is that if we have a bunch of mass trials and space trials, performance will improve very rapidly with the mass trials. Then if there's a break and a long delay, everything reverses. And on a delayed test, mass is worse, spaced is best. And this in the theory is because these mass trials will lead to a rapid accumulation of retrieval strength without a correspondingly strong increase in storage strength. And the forgetting between trials in the space practice case will both lower retrieval strength and performance, but enhance the gain of storage strength, which means there will be a much slower forgetting function here, and these two will cross over. Now, I'm going to stress sort of metacognitive aspects of all of this, and one thing to say is just has to do with the perils in real-world situations of interpreting what we might think of as retrieval strength, performance, as storage strength. What this does is makes instructors susceptible to choosing poorer conditions of learning over better conditions, and students become susceptible to preferring the poorer conditions over better conditions. Give you some examples. And in order to optimize learning, there is a need to introduce what I've come to call desirable difficulties. Having coined this term, I'm beginning to think is a mixed blessing. Just a few days ago, Doug Rohr, in an email to Elizabeth, at the end of it said, oh, and tell your desirable, if difficult, husband hi. Because forgetting can enable learning, conditions that appear to create difficulties for the learner, slowing the rate of apparent learning, often optimize long-term retention and transfer. At the same time, conditions that make performance improve rapidly often fail to support long-term retention and transfer. And this can lead to students and teachers alike getting fooled. Examples of manipulations that introduce desirable difficulties: varying rather than keeping constant or predictable the conditions of learning, distributing or spacing study or practice sessions rather than blocking, using tests rather than presentations as learning events, providing contextual interference during learning. This is a set of manipulations that share the property that you should arrange the separate things to be learned in a way that maximizes the possible confusion and interference between those things to enhance long-term learning. But what that will do is slow down apparent learning. I'll give you a couple examples of one instance of this: interleaving separate things to be learned rather than blocking them. Oh, I always have to emphasize the word, having talked about this to some general audiences, I have to emphasize the word desirable is important. Many difficulties are desirable during learning, after learning, forever after. I a few times talked and more or less, not in so many words, but had somebody come up and said, you know, I have been confusing my students for years, and now you tell me it's a good thing. They're desirable because responding to them successfully engages the very processes that support comprehension and remembering. And we could go through each one and say what those are, but I'm going to stay at the kind of descriptive level today. In fact, desirable difficulties become undesirable if the learner is not equipped to respond to them successfully. So, for example, we know that generating is a very important thing to do. But if you as a learner are not equipped to generate, if it fails, then that's not a desirable difficulty. Couple examples of interleaving versus blocking, one by Dominic Simon and myself. The advantages of interleaving over blocking were initially shown in motor skills research and now are being extended in a number of ways, as the next study I'll show you. But Dominic Simon and I were interested in is whether people were fooled by their own current performance. So the task involved, on a number pad, learning 3 different keystroke patterns. And so in each case, there was a start key. You had to hit those keys in succession for this pattern, these keys for that pattern, this keys for this pattern. The tough thing about it is that the whole thing had to be executed in a certain target goal time. So those 3 were learned, and you got the trials on one of them either blocked or interleaved with the trials on the other. And as far as that goes, they got feedback as to whether they were correct, how far they were off on the goal movement time, and so on. But our results actually replicated all of the many studies in the motor literature that during the training you were better blocked than you were random, but on a test 24 hours later, now there is a very big advantage of random over blocked. And these are blocks of trials, these are critical trials, that's why this is so much hard. But basically, at 24 hours, you appeared not to have learned much at all in the blocked case. What we did was every so often we stopped and we said, if we stop the training right now, how close do you think you can come to the target movement time on this pattern tomorrow? We told them exactly what would happen 24 hours later. The people who had gotten random training, actually, whether they were asked during the training itself or right 24 hours before they had to perform, were pretty close. The people who had gotten the block training were wildly overconfident. Basically, they were indeed fooled by their own performance. Now, in a case that's particularly surprising, and surprised us, in fact, is the first of a recent series of studies we've done on optimizing induction, the ability to generate concepts and categories through exposure to multiple exemplars. And the top case is spotting malignancies or whatever in X-rays. The bottom case, examples of paintings all by one painter. That's the material we used in the studies that I'm going to tell you about. But if you'll just look for a moment, and I tell you that this penguin's a Gen 2, this one's a Gen 2, that one's a Gen 2, that one's a Gen 2. Where's the Gen 2? Somebody tell me. Upper left. Now, we didn't show that picture, but you could extract the commonalities from the pictures we did show and generate some sort of concept of Gen 2 as a penguin. And the notion we had initially is that this is one case, blocking massing, where blocking and massing might be superior. They would let you, across 4 exemplars like this, notice the commonalities that define the category, whereas if you had one here and then 2 other, a Lachesis and a Reinhard, before seeing another Gen 2, it would be difficult to extract the thing that defines the category Gen 2, or so we thought. And we were also trying to test this notion. The great man, the dean of educational psychologists, Ernst Rothkopf, once said this somewhere, and most of us filed it away. We can't find it written. Spacing is the friend of recall, but the enemy of induction. He said it with the kind of authority that we just believed it and didn't do anything about it. Now, in the experiment, subjects saw, they saw paintings by a given painter either blocked, like that was Lewis, and that's Lewis, and that's Lewis, and that's Lewis. And now, did you induce Lewis's style or not? Could you feel it sort of coming out? That would be those paintings, but subjects saw 72 paintings total, 6 each by 12 different artists, and some of them were blocked like the Lewis paintings or Hawkins down here, but the rest of them were interleaved across these sessions where it's S for spaced. Then the final test, they saw new paintings that they'd not seen before. We didn't make them recall the names were down here of the artists. They just had to try to identify which of the artists they studied had painted this new novel painting. And to our surprise, spacing, interleaving was better, not massing and blocking. Must have been a bit of a surprise to our participants too, because after this test was done, before they left, we asked them this question: which do you think helped you learn more, massed or spaced? And they could choose massed, about the same, or spaced. Actually, that's how it was across subjects. That's what they said. So in spite of having just performed better, given interleaved presentations, they thought that massing was what helped them learn. I won't pursue this. We're pursuing a lot of different ways. We've tested this with, it's been shown to be hold for 3-year-olds learning the names of novel objects. Then we thought elderly participants might need the support of massing. They showed an interleaving benefit. And now the new hypothesis is that interleaving or spacing highlights the differences between artists, and that turns out to be more important on the long run. Just to protect Ernie Rothkopf a bit, I should say that we have found if we make it hard enough, nearly impossible to remember prior exemplars, Ernie turns out to be right. Then you do have to mass. Recently, Rohr and Taylor have shown of educational significance. If you're having people learn like this, the volumes of some irregular solids like a half cone or a spherical cone, if you interleave examples or problem solving, you get far better recall at a week, though at the end of the training session, there's better again with blocking. That would seem to have some educational significance. Why remembering causes forgetting? As Michael mentioned, this traced back to early ideas on retrieval as a memory modifier, that using one's memory shapes one's memory. Information and skills that are retrieved become more accessible. Information skills associated with the same cues in competition become less. And that has led to the development of this retrieval practice paradigm. And quickly, in the initial version of the paradigm that Anderson, Bjork, and Bjork carried out, there's now many versions of it and many arguments as to what's going on. There was a study phase of 48 pairs, 8 categories with 6 members each, then a retrieval practice phase in which you practiced in the way this fruit OR cue, which meant which of the fruits that you studied begins OR, a pretty easy retrieval. You retrieved each such member of a practice category 3 times, and you practiced half the members of a practice category. Then there was a retention interval and a final test that takes different forms. This one shows just a category cued free recall. Often you control the order which you add test items at the end. Many different versions of the final test. But basically, if 2 of the categories were fruits and drinks, then I might test half of the fruits. Those are the RP plus items. And not test the others, the RP minus items, lemon, nectarine, and pineapple in this case. And then test none of the NRP categories. So what might we expect the effect to be of testing some items in the category? Well, if we test orange, one notion was, well, maybe activation spreads to other members of the category like lemon. Turns out, to reveal the results ahead of time, that in fact selecting orange appears to inhibit access, or in the language of music today, kind of reduce the retrieval strength or accessibility of lemon. And so if we compare practiced and unpracticed categories, there's a positive effect of practice for orange, but rather than being a positive effect for lemon, it's a negative effect. And so if we compute a kind of different score, then there's a benefit of a large benefit in this particular experiment for orange, but that's accompanied by a penalty or a cost for lemon. So there's a whole body of that work now in so many domains that I think Mike and Elizabeth and I couldn't have anticipated it early on. But one other thing I wanted to show you that sort of ties together the forgetting and relearning is a recent experiment by Storm, Bjork, and Bjork. Now, we noticed that the new theory of disuse made a kind of perilous prediction, which was if retrieval-induced forgetting lowers the retrieval strength of the RP minus items, it ought to enhance their relearning. That is, if it's an induced forgetting, it ought to enhance learning. So this should be the prediction after relearning. So this is a little complicated and it's a little late, so you'll have to gear up here. In this study by Storm, Bjork, and Bjork, there are 3 phases. A study phase, 6 exemplars from each of 8 categories. A retrieval practice / relearning phase that I'll clarify in a minute, in which retrieval practice and relearning are sort of alternated. It took 5 groups of 48 subjects to do this particular experiment, so you should be impressed for that reason alone. 240 participants, a filled retention interval, and then a final test that was category plus STEM cued, as in tree M for tree maple, I assume. The retrieval practice and relearning procedures. In the retrieval practice procedure, 6 extra list exemplars from each of the 4 of the categories are practiced. That's something that has been shown to produce retrieval-induced forgetting too. 1 retrieval for each during a given practice cycle. The same 24 extra list items are retrieved during each retrieval practice cycle. The relearning procedures, 2 of the categories that are RP minus categories and 2 of the NRPs are relearned during the relearning cycle, and the remaining ones are not relearned. So an entire category with this extra list procedure, practice procedure, is either an RP minus category or an NRP category. Now, so that here is the 5 groups, and group 1 is a traditional retrieval-induced forgetting. You study, you do retrieval practice, you test. This one, you study, you do retrieval practice, you relearn, and you test. Study, retrieval practice, relearn, retrieval practice, test. Study, retrieval practice, relearn, test, all the way down to the last one. I'll let you extrapolate once more there. Now, so each one of these points, this is a between group comparison here, are the groups that I just showed you. And if inhibition persists, we'll just focus on the relearning things. Then across these cycles, the RP minus items, which are worse after retrieval practice, after relearning should stay worse. Then they should get inhibited some more by the retrieval practice. Then they should recover some. They never should sort of catch up. On the other hand, if it's just sort of released, we might find a pattern like the one shown here, Or, if this somewhat unintuitive prediction of the new theory of disuse is correct, then we should find that these RP minus items, each time they relearn, get a bigger boost than the corresponding NRP items and get this pattern. And you can probably guess that I wouldn't be showing you all that if the actual results don't look basically very much like that. So what's interesting here is it's sort of combining these two dynamics, that retrieval produces forgetting of competitive things, but that then positions those items to be relearned more effectively because forgetting enhances learning. And this just combines, shows the combined over those things, pre-relearning, post-relearning, and that as you keep subjecting items to retrieval-induced forgetting, their access gets lower and lower. Now, why does access to competing memory representations regress towards the early learned representation with time? Well, here, there's a lot to say, but I'll just give an illustration in the context of some collaborative work with Michelle Krask and her students in the UCLA department. So, one thing a number of you may know, particularly if you do animal research, is this regression to earlier learned behavior is very prevalent and sometimes very large. In this case, Boughton and Peck experiment, rats were first conditioned to shock. When a tone sounded, a shock was in the floor until the animals reliably give freezing and other shock-related behaviors. Then there was counter-conditioning. The tone was sounded and food was released in the food magazine, and that went on until the animal was showing just food behavior. Then if you take the animals out of their cages and come back in one day and sound the tone, you will get food behavior. If you wait 4 weeks, 28 days, and sound the tone, what comes out is shock behavior. Now, I've shown it actually works with food and shock turned the other way around as well. But this is important in the treatment of fears and phobias, which is what Michelle Krask and her students do. You treating something like a spider phobia, fear of heights, fear of public speaking, you can think as a therapist that you are making great progress in terms of what people are able to do across training sessions. But then when they're out in the real world, there's a return of the fear. And in the context of the new theory of disuse, this suggests that its storage strength of the original maladaptive responses is stronger than the newly learned adaptive responses. So in this characterization, if this is retrieval strength and this is storage strength, pre-treatment, you have both high retrieval strength and high storage strength of the undesirable, fearful responding. Then across trials during treatment, you make the desirable behavior, non-fearful responding, more accessible, reduce the excess of the fearful responding, but though you're increasing storage strength of the non-fearful responders, the idea is that the fearful responding is staying pretty much at the same level. And now, with time and events post-treatment, you'll see this crossover, and this will correspond to a return of fear. Now, this suggests that things should be done during treatment that are analogous to introducing desirable difficulties in order to change storage strength more, even if it appears that therapy is being less successful. And I can't show you all those results, but I'll just mention one of the most promising ones. This is with spider phobics. And what they did was a constant spider condition and a varied spider condition. This will give some of you queasy probably, but in the varied spider condition, each training treatment session they did where they measure heart rate and approach tendencies and all sorts of other stuff, there was a new spider. Now, I didn't actually know till I watched this there's so many different tarantulas. There's, in addition to that great big one that's in the movies, there's like a small yellow one that moves really fast. And they differ in all these different ways. Well, when it's a new spider each time, heart rate and other things seem to indicate that you're making less progress. But at the end of treatment and weeks later, when they do a final assessment, the varied spider case lessened significantly the return of fear. So again, that's the kind of condition that you might think would improve the storage strength of the desirable non-fearful responding and then reduce the return of fear later. Now, why is this overall combination of things adaptive? Well, forgetting's important. If we didn't forget, given the huge capacity of memory, even something as simple as coming up with our current home phone number would be difficult. It would be a decision process choosing that one from all the phone numbers we've ever had. But in human memory, rather than things being lost, they become inaccessible. So they don't interfere, but they remain there ready to be relearned, recognized under some circumstances, and that's adaptive. Using our memory shapes our memories. What we are accessing becomes more recallable, competing information becomes less recallable, and in terms of sort of need statistics, what is most needed tends to be most accessible. And that's because, in general, what we need in the near future tends to be from the recent past. Whereas if we stop using things from the recent past, that will often mean that earlier learned information is relevant again. So we spent 3 months in Scotland, sitting on the wrong side of the car, driving on the wrong side of the street, looking the wrong ways, a hazard to everybody. I got fairly comfortable by the end of this time, and now I stopped using all of that learned behavior. Why? Because we left Scotland, returned to the United States. Now it's actually useful and adaptive if the earlier learned habits of which side of the street you drive on, which side of the car you sit on, where you look for cars, and so on, come back. And that does appear to be the way that it works in general. A kind of library example. Suppose books A and B have both been accessed from a library 10 times in the past year, but book B has all this recent signing out, and book A has more distributed. Now, if you're trying to make a decision, if you have limited ready reserve space or something like that, which book should be there and ready reserve? Well, in the 13th month, which should it be? Should be book B. But suppose during month 13, the book is not accessed at all. Then which do you want to be accessible? Then it should be book B. I don't feel I made that clear, so drawing on another part of my research, just forget that part of it and focus on this. Finally, why do we develop faulty mental models of how we learn? Well, first of all, there's a number of misconceptions. That we think we work more like some recording device than we did. Watch your students taking notes sometimes. They're copying that thing down and they think writing that will write it on their brain. We fail to appreciate the multidimensionality of human memory. I've already mentioned that we're susceptible to interpreting retrieval strength as storage strength, but there are other dimensions too, as in episodic semantic memory. And I want to give an illustration with work by Aaron Benjamin, Benna Schwartz, and myself. And then there's a set of counterproductive attitudes and assumptions that we'll come to. In the Benjamin, Bjork, and Schwartz experiment, participants got 20 really easy general knowledge questions. Not all as easy as who was the first president of the United States, but so easy that our responding was almost perfect. The participants were asked to hit the enter key as fast as the answer came to mind, say the answer, and then they were asked to predict the likelihood that they'd be able to free recall the answer later when we'd ask them to recall their answers to all 20 questions. And Aaron can correct me if I have this exactly wrong, but Aaron held up a blank sheet of paper to make it clear that they weren't going to get the questions again. They would just have to try to recall their answers. Now, what we knew after distracting period, then indeed they did get that free recall test. What we knew from earlier work by Gardner, Craik, and Birtwistle, or Bleasdale, is that actually the longer it takes for an answer to come out, the better you will remember later having given it. It's a mini episode, and it becomes more memorable if you struggled with it a bit. So what we've shown here is we divided every participant's 20 response latencies into quartiles, and you can see that the longer it took them to come up, the better they recalled it. But what did they predict? I mean, one thing they could predict is they could say, well, I really struggled to come up with that one. I guess I'll remember it better later, which case this never would have gotten published. But they also adopted a heuristic. Things I remember quickly and well now, I'll remember quickly and well later, and that's what they did. Okay, so finally now, counterproductive attitudes and assumptions. First of all, I think we're susceptible to thinking that factors other than our own efforts determine whether we'll remember. There's a tendency among students and the population in large to just think that if things are just right, learning will be easy. Somehow that efficient learning is easy learning. There tends to be an oversensitivity to the kind of learnability of items. We're very sensitive. We're prone to think that determines our later performance rather than what we do or other factors such as retention interval. And I'm going to show you two examples of that and then conclude with some comments on differences in performance between individuals being assumed to reflect differences in innate ability or learning style, which is a counterproductive assumption. So Coriat, Bjork, Sheffer, and Barr looked at predicted forgetting versus actual predicted forgetting, and 60 paired associates. The participants judged pair by pair the likelihood they'd remember that pair on a later cued recall test. And the retention interval of the final test was between subjects. So some subjects were predicting for immediately after the study phase. Some subjects were predicting for 1 day from now. Some for a week. And the participants are very sensitive to differences between the pairs, related pairs versus unrelated pairs. But their judgments or predictions don't vary with retention interval, where actual performance drops off precipitously. And among whatever it was, 10 or 11 experiments, we even found that people's predictions, in one kind of ludicrous case, out to a year, they didn't predict forgetting. Now, we have followed this up by Nate Cornell and I looking at predicting one's own learning. So in this case, there are 24 paired associates that are either related, like Hill Valley, or unrelated, more difficult, like Clemency Idiom. And the number of study test cycles was between subjects in experiment 1. A given subject would get one study trial, then tested on everything. Study, test, study, test, study, test, study, test, study, test. And in each case, in this first experiment, they are predicting their performance on their last test trial. In the second experiment, we did it all within subjects. So for a given pair, the subject is predicting performance. They're all in this condition, and for a given pair, they're predicting performance on a given one of the test trials. Turns out, in this case, not to matter. So what you can see here in the blue line is what they predicted, and against they're very sensitive to relatedness, but they don't predict learning either. Given and versus actual performance improving dramatically. Nate Cornell and I labeled kind of both of these things together a kind of stability bias, the tendency to think that representations or memory are stable, not volatile the way they are, not subject to retention interval and study trials. At some level, people know that. At a general level, they know repeated study helps memory, we forget over time. But when they're focusing on the task at hand, differences between items and variables like that seem to block access to this general knowledge. Okay, individual differences in the styles of learning ideas. Some of you may know this is extraordinarily popular kind of industry and a movement, or it has been across the United States, that we can measure people's styles, and if we mesh instruction with those styles, that we will enhance education. It's a very attractive idea because, well, it could be true. That makes it attractive. But other than that fact, it says that we're all individuals. I think people like that idea and learn in different ways. That's sort of appealing. But it also says that if you or your children are struggling and not doing as well as you'd like, it's probably not your fault. If somebody would just teach in a way that fit your learning style or your kids' learning style, all would be easy and all would be well. Well, we reviewed all the literature and came to this conclusion. At present, there's no adequate evidence base to justify incorporating learning styles assessment in general educational practices. Limited resources would be better devoted to adopting other educational practices that have a strong evidence base, of which there are an increasing number. However, given the lack of methodologically sound studies of learning styles, it would be an error to conclude that all possible versions of learning styles have been tested and found wanting. Many have simply not been tested at all. Now, that may have very little effect on the market and practice nationally. And we're beat to the punch in terms of a little bit of this by The Onion. Parents of nasal learners demand odor-based curriculum. Backed by olfactory education experts, parents of nasal learners demanding U.S. schools provide odor-based curriculum for their academically struggling children. My child is not stupid, Ms. Weber said. There's simply no way for him to thrive in a school that only caters to traditional students who absorb educational concepts by hearing, reading, seeing, discussing, drawing, building, or acting out. But the real funny thing is the picture. This girl, a nasal learner struggles with an odorless textbook. A concluding comment. So, among the definitions of symbiosis is a relationship of mutual benefit and dependence. And as I've tried to illustrate, the relationships between remembering and forgetting are indeed symbiotic, but also complex and unintuitive. And it is overall a system that's remarkably interesting and effective if fallible, but it's no less remarkable by virtue of being so frequently underappreciated and misunderstood by the loser. But by the user. Thank you. The reason there are no, I threw away any number of final thank you slides with names on it, just so afraid I would leave critical people off. So I want to thank all of you, the society, all my former students, the colleagues who have been so important and so on, and have a good time at the reception.